Okay, good morning and good afternoon, everyone. I'm Chris Spinagle from the Warning Decision Training Division. Along with me is Jill Hardy, also from WDTD. I'd like to welcome you to our third installment of our Revival of the Storm of the Month series. Today's presentation comes to you from the National Weather Service Forecast Office in Wakefield, Virginia, and our presenter is Mike Dutter, who will be presenting 5 tornadoes in the same city, the localized tornado outbreak of September 17th, 2018 in the Richmond metro.
So as Chris mentioned, we're going to be talking a little bit about a tornado outbreak that happened a couple years ago in the Richmond metro. And as I said, 5 tornadoes in one city. There were actually 11 tornadoes overall in this day, which isn't a huge outbreak for across the country, but this happened in just in our little local area on this day. First off, want to wake everybody up, or you get everyone out of their lunchtime slumber, I guess, is where do you think the tornadoes are here on this picture? I'm not giving you a lot, but you have this deeper convection over here. This is across the Virginia Piedmont here, and this is Richmond right here. You do have some little bit of convection in the Richmond area. Not much to go off here. Let's bring up the radar over top of the satellite. A little bit more information, but still a lot of the deep convection is out here. That's really the best convection. There's a little bit of better convection in here as well. Well, you probably know the answer since I have Richmond stated right there on the map. All the tornadoes more or less on this day were right in that general area, and most of them were with these with these little mini supercells here out ahead of this line. None of the tornadoes occurred with this deeper convection itself. This outbreak, originated from Hurricane Florence, or the remnants of Hurricane Florence, as it moved on shore, and then several days later up through West Virginia and Western Virginia. Hurricane Florence made landfall early on the September 14th, 2018, close to Wilmington, just to the east of Wilmington, North Carolina, and it had a history of producing tornadoes. In fact, there were 31 confirmed tornadoes in South Carolina and North Carolina on September 13th through 16th. And this isn't surprising, right? I mean, we see tornadoes frequently with landfalling hurricanes, and this was no exception. So, it was certainly a tornadic, continued to have tornadoes, mostly in again, North Carolina and South Carolina for the 3 days following landfall. And remember how slow and how much flooding there was, obviously, with Florence as it moved through. So tornadoes, at least during this time, were important, but it was really the flooding and the flash flooding that was going on in the Carolinas that was the major concern. However, we return to September 17th. At this point, the remnant circulation had really weakened to just some type of a remnant low over West Virginia. And at this point, we were really focusing on ramping things down. It was, our office in particular was really ramped up for the hurricane landfall, even though it was well to the south. We still had, we had surge staffing from other offices, but on this day we were ramping down. I mean, the Virginia EOC was closing. If anything, we were expecting there was going to be some intense flooding over the mountains of Virginia, in Blacksburg's area and Morristown, and even into Charleston, West Virginia's area, some flooding. But in our area, we weren't really thinking there was going to be further major impacts from the system. However, we were wrong. There were, on this day, as you saw, 11 tornadoes total on September 17th. That's remarkable in itself, but probably what's more remarkable is that 10 out of those 11 tornadoes occurred generally within the Richmond metro area, generally in this map here, and five tornadoes occurred in the city of Richmond itself, which is, I don't have it outlined here, but it's generally this area right here is the Richmond metro, or the actual city of Richmond itself. And amazingly, only 9 other tornadoes have occurred in the city itself since 1950. So again, just an amazing cluster of tornadoes in a fairly short period of time. In fact, 8 of the 10 tornadoes in the metro itself only occurred in about an hour and a half, a 90-minute time frame between about 1846 and 2016 UTC. So, all these tornadoes occurred in a very short period of time, and all these tornadoes, which we won't get into much today, but all these tornadoes occurred right when schools were being released for the day, rush hour was starting up, and so needless to say, you have multiple tornadoes occurring during rush hour or during when school is letting out, really caused some major issues. Tornado rating wise, we had, as you would expect with tropical type tornadoes, most of them were small, fairly weak EF0s. However, we did have three EF1s, and unfortunately we had a stronger EF2, which did cause one fatality. Here's the picture of where the fatality occurred in a factory, which unfortunately a person was trapped within the factory. Even though they did receive the warning and everything, that the person was still unfortunately trapped in the factory. This is a loop of our radar from about 1830 to 2037 UTC. This is really the only major radar imagery I'm going to show today. There's a few little insets that I'll show. This presentation is really going to be more about the environment and the some of the mesoanalysis of the event. But I just wanted to show you how rapidly these tracks almost accumulated on top of each other over this 2-hour time period over the city of Richmond. And again, notice how all of these tracks were concentrated with these weak-looking mini supercell type structures out ahead of this leading line versus the actual line itself. And notice this little feature coming up from off the frame and into the Richmond Metro, especially the eastern part of the Richmond Metro. That's something we're going to be focusing on a lot more in the coming slides. But I just wanted to show this just to show how rapidly the tornadoes accumulated on themselves and how quickly this event evolved from almost nothing to a significant event for the area. So starting out in the morning hours and even in early morning hours and when at first light, the thought from everybody from the WFO here to SPC was that the best threat for any severe weather, and it would be in the form of some tornadic supercells possible, would be really west of the Richmond metro area, over the Piedmont and foothills and even into the mountains, Appalachian Mountains of Virginia. And this made sense at the time because all the guidance, and I'm just showing the HREF, STP, and the 0 to 1 SRH, really pegged areas, again, west of the metro area for having the better, least parameter space for tornadic storms. This forecast made perfect sense. And again, remember, I don't even get into this at all, but the big focus for this day wasn't so much the severe threat, it was the flooding threat across the western part of Virginia into West Virginia. So it was a challenging forecast at the onset. And to just get into a little bit about the mesoanalysis and the little couple slides, what the environment was looking like as we got closer to the event. Next couple slides are going to show a couple charts from various levels from the SPC Mesoanalysis at 18Z. And this is the first one at 500 millibars that shows there's a decent southwesterly flow of about 40 knots across the area and a little bit of upper diffluence across the area. Nothing greatly strong, especially for a tropical remnant tropical system coming through, but there was decent mid-level flow. Now we go to 850 millibars, and again this low associated with the remnant of Florence. You do have a weak trough, or quasi-warm front, whatever you want to call it, but some type of a trough just across northern Virginia and extending down into the eastern shore and then off the coast. We do have, again, decent lower level flow of about 30 to maybe 35 knots across much of the region out of the south. One thing to note, though, is the dew points are very high, as you would expect, at 850 with dew points greater than 15 Celsius. But again, nothing extravagant, nothing very strong for, that you would expect, with a tornadic day. Now this is at the surface, and this is again from the SPC Mesoanalysis, and we're going to be talking a lot more about the surface in the coming slides, but One thing I want to note here is it's a very simplistic surface plot, but one thing I wanted to note is how you see the the remnant low here, but then the very subtle kink in the isobars that's extending down into southern Virginia and off the coast. And notice how you have this very subtle backing of the winds. This was not analyzed very well by anyone, including us at the office, WPC, anyone, but this was really the important player in the event. And again, I'm going to be talking about that a lot more here shortly. One last slide, for completeness with regards to some of the stability and shear parameters. Again, we have a decent cape across the southern half of the area. We're certainly in this cape gradient, and we know a lot of times bad things can happen in gradients, not necessarily the max area. So we have a sufficient cape. I mean, 1,000 to 1,500 joules of ML cape is certainly sufficient. The 0 to 1 shear was 25 plus knots, which again is not terribly strong, but certainly strong enough for potential low-level tornadoes and tornado genesis. The STP supercell tornado parameter, just to show, wasn't very strong right at this point. It was only about 0.5 or less across the Richmond metro. But again, the strongest values were generally west of the area, west and south of the Richmond metro. Now here's the 1630 UTC outlook from SPC, and one thing I wanted to note here that's very important is how SPC did shift the marginal further to the east, which was a great recognition on their part. And we did have one tornado already about an hour or so before this outlook already occur across Mecklenburg County down in this area, but still it was a great recognition that to expand this marginal further to the east. Even though some of this 0 to 1 shear change was actually lower, you're actually decreasing 0 to 1 shear, especially south of the area. Certainly we're not increasing it at all. But the one concern still, not to upgrade it even further to like a slight risk, was that everyone thought the threat would be diminishing actually as the shear decreased through the afternoon. So the big question is, why did we get this 2 hours later? Why do we have multiple mini supersols at pretty much at the same time? So this is the main question where I want to focus the last 8 minutes of my talk. This is a loop of the GOES visible from about 15 to 21Z, and you're going to see a lot of things on here, and I'm going to try to highlight some of these for you. First of all, and this will keep looping as we go through. First of all, a lot of this deeper convection, as I mentioned at the beginning, was not where this was not where the tornadic activity was occurring. Again, remember, focus on this area in here especially. The next thing to notice is how, and remember in the previous slide how I had showed that cape gradient. Well, that is partially due to the fact that we had a lot of cloudiness in the Richmond metro area through early afternoon, really. But that rapidly gave way to at least some partial clearing an hour or two before the tornado started, before the tornadoes developed across the area. That certainly helped with the instability. And then last but not least, and this is what I'm going to zoom into closer, is if you look very closely, and again, I'll zoom into this in the next slide, but if you look really closely, look at this boundary. Remember I talked about this little line of showers moving north, but notice that just north of this boundary, notice how the cloud vectors, the lower level cloud vectors change from more of a southerly direction or moving to the north to more of a easterly or southeasterly, or moving to the west or northwest just north of the boundary. Really, this I think is the key to this whole event right here, is that change of low level wind vector. And let's look at this a little bit closer. This is a rocking loop of between 19 and 20 Z, so very focused and very, just about an hour loop. This is the mesosector from GOES 16, minute by minute. And you can see where these low, especially in the circled area, how you're seeing those low cloud vectors change direction as they across, or at least as they get further closer to the Richmond metro. So there was most certainly a change of low-level wind flow, right over the immediate Richmond metro area. With that being said, all of these storms, and again, this is the radar and satellite overlaid, and remember that these low-level showers and stuff that we saw on the radar earlier. All of these storms, all these tornadic storms, were actually along or just to the north of this boundary, and helped to create sort of a localized maximum of SRH by backing the surface winds just to the north of this boundary. But that was very tough to see in real time. And in fact, I have these last couple slides I have are some surface analysis to the left and the actual satellite picture on the right of what we were seeing in real time at the office, and how the wind flow changed with time. So this was at 17Z. You can see a lot of cloudiness over the Richmond metro, and you have this weak little, you could argue there was probably some type of a subtle boundary there. It's really tough to see at this point. There's maybe a slight change of wind direction here, especially to the north and east of the boundary. As we go to 18Z, again, this boundary is moving north and east, mainly north though. You can see it a little better defined now. There's definitely a difference with all this cloudiness. Much cooler temperatures in the mid 70s up here versus low to mid 80s down south. And again, the winds, the low-level wind vectors are backing even more. 19Z, and this is about right before the majority of the tornadoes were within the hour were going to develop. And we see here that at this point, again, the winds have backed even more. They're almost to a due easterly or east-southeast direction across much of the southern metro. And you're even starting to now see some of the clouds break up here, just enough to where, you're at this point getting to see at least some partial sunshine and some solar insulation to help with the potential instability. And then by 20Z, at this point, the tornadoes are actually ongoing at this point, and much of especially south side Richmond, right along and north of the boundary. But notice how, again, these winds have continued to remain backed at a east-southeast direction. Very warm just to the south of the boundary. You may not be able to see it very well, but that has 86 in Petersburg, so very warm at the south of the boundary. And this boundary right here was the driver for this entire event. Again, very focused, a very small boundary, but nonetheless very important. So there was a boundary, great, and we can see that now. But what was that boundary exactly? It wasn't really a warm front, necessarily. I mean, you could maybe call it one. There was some type of a temperature difference across the front. But when you look at the HER 0-hour analysis, which I have here, and this loops from 15Z to about 20Z, and this is potential temperature I'm looking at closely at, you can see that the HER analyzes this very well, this boundary. It was actually, I believe, some type of a differential heating boundary that was associated with the extensive cloudiness to the north, and then the breaks of sun to the south. And again, that helped to actually reinforce or actually generate this boundary that helped cause increase that backing of the wind just to the north of the boundary itself. So and mainly focused on the Richmond metro. So one last slide here before we conclude. These are just AKQ, the rate 88D bad wind profile derived photographs, and this is from about 17Z, so a little bit before the event, but again, you get the idea. The left is using the surface wind south of the boundary, and the north one is using a surface wind, or at least one that's somewhat representative of north of the boundary. And you can see that most certainly your shear, 0 to 1 shear, especially shear and SRH both increase of south of the boundary. It's around 19 knots of shear and about 148 SRH. Compared to north of the boundary, it's about 25 knots of 0 to 1 shear and about 190 meters squared per second squared of SRH. So not a huge difference, but certainly in this case, most likely enough to help with tornadogenesis and just to the north of the boundary and over the Richmond metro. And the 19Z mesoanalysis did actually pick up on this very small area of, at least in the STP, of better shear and better instability, just from using the STP. But unfortunately, the office would have never seen this in real, or at least before the tornadoes happened, because it takes a little while for these mesoanalysis graphics to generate and show up. So if anyone takes anything out of this case, is that the detailed analysis and a detailed mesoanalyst is critical, even in marginal type severe cases. So that's all I have. Here's a couple best practices. Really, again, I think in this case, in any case, but even in marginal cases, a dedicated mesoanalyst is just a must. And utilize these rocker type loops and feature following zooms. I'm a really big proponent of these on AWIPs. I think they're really great. Sometimes they're not easy to get going, but if you can do it, I think they're really helpful to identify features, especially these subtle features like that you can really show. And we all know the SPC Mesoanalysis is great. However, watch out for those rapidly changing conditions like we had here. And again, sometimes high-resolution analysis or near-term forecast can provide very useful information. A lot of times we look at some of these smooth fields and stuff, and those are very valuable. But even high-resolution information can be very useful as well in an analysis sense. That's all I have. So I will be happy to take any questions. And again, I thank you so much for listening today.
With that, I'll go ahead and call the end of the presentation. I want to thank you again, Mike, for this presentation. It was really well received and very interesting. We'll see you in 2 weeks.